Okay, are we live? Okay, so hello there. Today we will continue our messing with the embedded Rust on our blue pill. So previously we added a temperature sensor or temperature, humidity and pressure sensor, and we hooked up a LCD display. So we're using SPI to talk to the LCD, and we're using I2C to talk to the BME280 sensor. So there's small changes to our setup, or should I say improvements. Boom. We can have a look at our stuff here, and I added those 3 buttons to our STM, and we will see if we can the buttons working today, and you know, put a little bit of more interaction with our system. So I hooked it up to the 3 pins, which is this. Oh, actually, I just realized that I'm not showing the mouse cursor when I'm pointing at stuff. So I just want to fix this really quickly. Okay, so my cursor should be visible now. So basically I hooked up the 3 buttons to the PA11, PA12 and PA15. So our problem is that PA15 was the pin that we were using for our PWM output, so we will have to change that as well. Yeah, so I guess let's just start working on this. Okay, so let me just remember where we are. Okay, so that's our BME sensor stuff. Boom. Okay, so we will initialize the pins. So we will want 3 buttons. So basically the way I was thinking is that we can have like a directional 2 directional buttons and a confirm button. So left, right and enter, I guess. So our enter, left and right. So let me just see how I hooked it up. So I guess our enter can be our PA15 pin, and then PA11 and PA12, something like that. So that means we need to take our PWM output pin and move it downstairs, but that means we can probably use, because we don't use it for anything else, let's say, and it's also timer 2, channel 1, so we can just take it from here and move this into the pin PA0, and that will require a very minimal code changes on our side. There was no reason initially to choose the PA15 as our output PWM port. well, there was a reason. The only reason was that I wanted to show you how to remove the JTAG config or the debugger config out of the pin. But yeah, we might as well use the ADC or the PA0 pin for this now. So that means that we can take this, delete it, and use it here for our enter button. Yeah. Okay. And that means that's not, and we will finish the configuring this later on, because it's not going to be alternative anymore, it's going to be input pin. But now that means that we need to configure the actual PWM pin. And we decided to use the GPOA PA0. Control register high, forgot, or log. Yeah, and then we need to update, because we hard-coded the type that we were passing in there. Blah, 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 blah. So let's find our clone. There. It's here. So this is going to be 0, and that means that there will be no remap. We will use the res in a second, and that's a no remap. Yes, and we need to change it down here as well. Okay, so that's done. So now let's finish our config. So this is going to be PA. Yeah, so we should be, so we need to turn this into input, no, push, pull up, what is it, into pull up input, into pull up input. And again, and we need the control register low. POA control register low. Okay, it needs high. yeah, because that's probably the lower part of it. Yeah. Okie dokie. So basically, so that should configure the output as a pull-up. And that essentially should be that should be already configured to read whatever we have on our buttons. So basically, whenever we press the button, it's going to pull the circuit or pull the pin to the ground, which will in turn make it as 0. So normally it's high, we press the button, goes to 0, and we can see the state change. We can simply just read the pin in our idle loop and see whatever, basically keep polling it at whatever time interval, and just await the state of the change of the state. But we can do it a little bit more professionally, possibly, and we can use the EXTI interrupt. So what is it here? So this is an external interrupt which we can configure on those pins. So basically, every time the pin changes state now, it will trigger an interrupt, and basically then we can do whatever we want to do with with that event. So yeah, so basically again that will free up our idle loop, which is this, to, for example, display the stuff on the screen or whatever updates there is, and we will have the interrupt routine handling or firing whenever the state on the pin changes, whenever we press the button, and just do whatever. So we need to configure the interrupt routine. So for this we need to check the interrupt enum, because I don't remember what the interrupt is going to be called. So basically, according to the datasheet, so what is it? Main features 2007. So basically, each of the pin is mapped to a specific interrupt routine, or the interrupt vector that's going to fire when this pin changes state, if it's configured as an interrupt pin. So basically that means that this interrupt routine will fire whenever any of those P0 pins changes state across all of those ports. So in that case you will have to basically make a test which exactly of those pins changed state. So it goes all the way to the pin 15. However, that doesn't be the case in here, and in here, for example, the pins 9 or 5 to 9 share further the interrupt vector, and then again in here. So that means that this is the name of the interrupt routine that we have to use when configuring it. And within it we will have to make all of those tests to figure out exactly which pin triggered the interrupt. Okay, so basically that's going to be, I think, similar to this. And in here we're binding this to the EXTI, what was it, 1510. But our resources are going to be different, but we will leave it for the time being. And EXTI 1510. And we need to use this name in here as well. Probably you won't need that counter anymore. I just want to clean this up where possible. Okay. So now we need to configure those pins we need to essentially configure those pins to fire the interrupt whenever the state changes. So let's see the example. So this is more or less what we're using. It's just that, remember, we're using the Arctic scheduler for our stuff. So we won't need any of this ugly stuff. But right now we're interested in this. They're using floating input, but in our case we're using the pull-ups. Okay, so that's going to be this, like that. Okay, so looks like we need the EXTI, we need to import the trait. So here. Okay. And in our case, we have it in the device peripheral. And we need to import the edge. Where is that? It's from GPO. So also here. Okay, okie dokie. that's looking good. So the only difference is that this has to be mute. Okay, that's looking good. So that means that we can pass those buttons in. So and left and right. And we need to tell our resources struct that this is what we want. So enter SPA 15 configured as left is 11 and right is 12. Okay, but what's going on here? Expected comma. Oh yes, we're missing one of those. Boom. And we need to import the input type. And obviously I made a mistake. It's pull up. There. Okay. So so we have this. So that means we can essentially start adding this in here. So we will have the left, the right, and the enter. So that means that we can. So how we want to do this? So enter is context resources enter. This is going to be left, right, right. So that means that enter left, right, enter left and right, and we can check them in that case. So in here we don't have to do this because the Arctic looks after all of those interrupts or global interrupts set up for us, so we don't have to call this explicitly. But what we need to do is basically just change the check the interrupt and then make sure that we are clearing up after we finished processing the state of the pin. Otherwise we won't be able to, or otherwise the interrupt won't be able to fire again. So we will need to leave this for the time being. So actually we will have to run this for all of those guys, I guess. Like that. But let's see what was fired. So basically we will need to check. So for example, if the enter was, so check interrupt, check interrupt, so if that's the case, we need to set some sort of flag that will keep a track of what's pressed and what isn't. So let's define an enum maybe in here. Button state, I guess. Okay, and it can be either enter, left or right. Okay. And maybe none as well, because we want some sort of initial state as well. So that means then we can just add it in here. So button state, and its type is button state, and we can use this macro to initialize this. So then that means that we don't have to then initialize it in here explicitly. We can just simply take it in here and button state and just use it here. Resources like that. Yeah, that's this. So if check interrupt, if button enter check interrupt, you can have button state dot lock and button state equals enter. Does that work? Oh, it's confusing the enums. Is that even allowed? Button state like that. Yep. Cannot borrow was muted. Yep, we'll get there. So this, okay, and that looks like it's allowed. So then, so we can continue this. Else it's none. That looks fine, I guess. Okay, so here we can change this. So actually, one thing, because we don't want to only check the interrupt in here, we want to check the interrupt and also check that if it's exactly is, what is it, set low result. Like this. It's low. Yeah, and we need the trade. Yeah, but basically we need to do this for all of those guys. Yeah, and we need to import the input pin from version 2. Okay. So then since we have this, that means that we can just take the button state and use it in here. Button state and use it in here, and that means that we can print it somewhere here actually. So we want something like so there, button, and we need to basically first read it. Button equals, what is it? Button state clock button. Yeah, we need this here. And this has to be immutable, yeah? Okay, looks like it doesn't. Yeah, so for that we need just this. There. And yeah, that needs to be immutable. Yeah, because we'll try to copy in here, so let's just be lazy and copy. There it is. So yeah, add the button, blah blah blah, clear. That should be enough. We probably don't want this anymore. We will know that all of this is well tested and ready to roll. Let's start here, something like that. So cargo and release. Hopefully we will see it in here now. We have some okay, so we have some issues there with the screen. Why is that? So we're printing this. There. Okay, better. Not sure if so. Button is none. Left, right, or enter. Okay. So that's, I guess that's a good progress so far. Okie dokie. Yeah, so I guess we're reading the inputs now. So that actually went semi-quick. So I guess we could probably try to, instead of just doing something like that, well, first of all, let's see if we can enlarge the fonts a little bit, because this is itsy bitsy too small. Goes here, there. What other fonts are there? Yeah, so maybe this dude, 18 by 6. There. And also here. We probably have to adjust our actually no, that should fit in probably. We only doubled. Okay, so we should have done this straight away. So yeah, let's maybe try to add a little menu that we can just maybe just like 2 pages or something like that, that we can just swap with the buttons and maybe confirm. I don't know. We'll see where we get with this. Okay, but this is getting a little too large as well. So maybe let's see if we can move this and this to a separate file. So maybe the tone rs. Okay. So boom. Let's add it here. So mod tone. Okay. So we will need to grab all of this. Let's see what we're missing. Though we don't use stuff from previewed anywhere else. Okay. Consider importing. We are importing it, no? Okay, so that one will be create. We will use it here. Like that, and what else? Oh yeah, it's not here. It's actually here. Consider importing the struct. What does it mean? So we just need to clean this up in here now. So no embedded graphics, not this, not this, not this. No GPO at all. Not this. There. Nice and simple library. Okay. And we probably want to move the display as well. This and so we start from this. Boom. And all this. Okay, so those are pretty misleading. So where's our display stuff? Use create display. Oh. Okie dokie. Okay, that's the usual stuff. So yeah. This. Okay, we will need because we defined this as a different type. So we need to find the type this. And that means we did need this after all. Boom. Okay, and we do need those. Okay, so now we just need to clean up this. And then Okie dokie. So since this is all clean now, let's go back to our main and see how we can make this menu working. So what we will want some sort of just a simple header maybe at the top of the screen, which will show us kind of like the page or the view, and this will be, we will be able to swap this with the left right button, and then by pressing enter we confirm and we get presented with the content of that view, I guess. So yeah, we were displaying temperature, humidity and the pressure. Okay, so actually let's go back to where we had the display, and we will define the menu in here. So public enum, so public struct menu, and the menu, so it will have some sort of pointer to the current element within the menu, whatever, I guess. And we will want the menu itself, which can be an array of, I guess, strings. Yeah, so you know, the temperature, the humidity and the pressure. So actually let's do the menu item, and that's going to be our enum. Yes, and we will have the temperature, the humidity and pressure. And like that. Yeah. So let's just input menu, and yeah, we will just create a new one, and so the menu will be just the temperature, the humidity and pressure, and our pointer by default starts as 0. Okay, and I guess we can do the forward, and yeah, which will take the move to self, and in here we will just increment the pointer. 1, so that we can swap the menu items, and we want the same for backward. But here we will go the other way. Yeah, and here we have to make sure that we don't go out of bounds, because this is an array. So if the pointer is, so here going forward, and we only have 3 elements. So if it's greater than 2, we want the self pointer to roll back, so it's then 0. And we want the reverse situation in here. So if self pointer is less than 0, we roll back. Pointer is equals to 2. There. And yeah. And then we want to return the current item element, current menu item, yeah, and that will return the menu item. So self dot was it menu, and pointer. That has to be as size. No, where are they? Cannot move. Yeah, this is going to be a simple type, so we can just take and derive copy and clone. Yeah. And so that's for our left and right, and we probably we want some sort of confirmation when the enter is pressed. And like there's no point of adding an accessor for this, so we're just gonna make this public. Start as false. Okay, this is looking, I don't know how. It's looking neutral right now. So display, yeah. So we want this menu as well. And we will want the menu item, I guess, as well. There. So that means that we can change our logic here in our interrupt handler, the external interrupt handler. So actually, yeah, we need to pass it in there now. So we want our menu, and our menu is of type menu, and we want to initialize this just as the previous one. So init So the start works. New. Well. I like it. So then we need to take our menu here. So button state, so menu. And like that. Oops. So menu. So now instead of instead of this, we can just menu dot. So if we press enter, confirm equals true, and here we can just go on menu dot. So if we press left, we go backwards, I guess. We go backwards, and here menu go forward. Does that work? And no button state. And I guess nothing here. Oh. Backward, I guess. There. And this doesn't matter. Calls in statics are limited to constants. Okay. So we cannot do this after all. So we need to do this manually. Okay, so I don't think we need this anyway. So here we need to initialize the menu manually anyway. So load menu. Boom. It's menu. And we don't have button state anymore. To 20. Yes, okay. Okay, so then that means that we want to print some sort of header, and it will print a different text depending on the current item within the menu. So maybe up function render header, what do you call it, a tab view. It's a header with a tab, I guess. So we need a self, and we will want the menu item. Yes. So let's print some border, maybe. We just need to see how to do this in embedded graphics. So a simple rectangle. Fill color. Can you do like a border? Circle some text. Oh, there, something like this. Draw a circle, draw a triangle, draw some text. Oh, but we're using the latest one, so let's make sure we're looking at the right one. Okay. What? Has this changed so much between versions? Okay. So what do we want then? Just like a simple, something like that even. So yeah, something like this. Tick stroke. Like that. Don't use any text style. That displays the tick stroke. There. So it displays size. So this displays it around the whole display. We don't want that. So we will want it just maybe, what is it? The full width, but just a small header, like maybe 20 pixels. So size new width, our width is 128. So what we want is only like 20 pixels. Okay, and we want to import all of this. So embedded graphics, what is it? So we want prelude, we have that. we want a binary color, pixel color, we want a binary color. Okay. Yeah, we don't use this. We need to unwrap here. We will need to look into some error handling here. And primitive style. That's in style. Okay. And oh, we need a rectangle which is in primitives. Primitives rectangle. There. And the display, get that from self. Like that. Why is this? Ah, this is because of the yes. So we need to go here, RGB there, and what is it? Are we gonna risk flamboyancy again? I don't know. Let's say magenta. That's such a self-explanatory color. Okay. So that's that. Okay, and so let's see how that looks then. Because that should give us some idea. Oh, but we didn't call that function yet. In here. So blah 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 display. Yeah, that's perfect. Display here and then render. Top header. And it needs the menu item. We just give it whatever for the time being. I just want to see the rectangle being rendered. Boom. Okay. That looks exactly like something that we want. So that means we can just place a text within it. So it has the 20 pixels size. The thickness of it is 3 pixels. And our text is 16 pixels in height, so we have plenty of room to stick it in there. So that means we can just match on menu item now, and if it's menu item, so temperature, what we want, the so self print text and temperature. Oh yeah, and so we have to position this in the middle of the header as well. Okay, we'll see in a second. So I guess 10. So we actually want the text here, and this is our temperature. This is text, and here we want to calculate the length or the position of it on the x axis. So our screen is 128, and we want to subtract the text len. And we want to divide this by 2. Because there. And we want to do this for each of the element or each of the elements that we support. Okay. Let's just make sure that we're render it correctly. Okay, so it's too low. Yes. I'm being silly because the well, first of all, we want this right under the border, the top border. So if the border is 3 pixels, we can, yeah, let's do it 5 actually. We will have like a 1 pixel of headroom. And the second is that each of the character of the text is not 1 pixel, it's actually 8 pixels. So we need to multiply the by 8. I think. There. So actually we can probably put it itsy bitsy higher. So yeah, it could have been 4 after there. Okay, so once we have this, that means that now we can take the menu, which is here, and just so let's menu item is menu dot lock menu item actually no, that's still menu, and here post get current menu item. There. And I think with this we should be able to now change it with our button presses. Okay, it's still a little too low. So we can go upwards and backwards. Okay, so we just need to do a little bit of tidy up in here where we print this. So okay, so that could have been even that. And then how to do this? Probably want to get rid of this flickering. But I think the flickering is only because the text overrides the bottom part of the edge. But we do need to clear the area where the text is displayed. We could probably just write an empty text in there. That feels a bit hacky, but I guess this is what we're gonna do. So the longest word is temperature. There, just want to yank it and display it in here, and we just want to clear it. Okay, that's disgusting. Okay, a little bit better. No, actually no. No, it's still actually a little bit. We need to slow down the main loop a little bit, or make sure that we are rendering it only when we actually press any buttons. So yeah, we can probably add this later on. One other thing only is that we can move this a little bit lower. 2 pixels lower probably. Yeah. And then that also means that we should be rendering this first. So at the very top. And then any potential error is here, way below. Okay, so the last thing that now we want to do is, so instead of just changing it like that, okay, so one other issue is the bouncing. But we will look at this later on as well. So sometimes there it is. I only press once, but it changes multiple times, and that's because of the bouncing of the switch during the press. We will have a look at this later as well. Okay, so these renders are header, but in that case let's print the temperature only on the temperature screen, the humidity only on the humidity screen, and the pressure on the pressure screen. And let's only do this when we press our confirmation button. Yeah, so we are setting our confirmation bit, menu confirm, in here. Okay, so let's see if the confirmation has, or the enter button been pressed. So like that. Let's read the value. So menu confirm. What's going on here? Oh, I cannot have this in the I cannot have this in this place. It should have been here. So let's read the confirm value, and then we will match again on the menu item, and then if menu item is the temperature, we display temperature. like that. Okay. And only if confirm is true. And then we do the same for the rest of the dudes. And then we will have a catch all that will simply do nothing. And we will remove this. So that means that yeah. And then we will make the menu lock menu m.confirm equals to false. Okay, and what do it is? Binary color. Ah, yeah, it's still when we there. Oh, come on, Rust Analyzer. It's still flickering, but that's because our loop is a little yes, because by default we don't display anything. So let's display humidity and boom, temperature, even though we wanted pressure, boom. Okay. So that's our little menu that we have. Okay. So there's a couple of small bits and pieces that we can still look into improving. Like maybe this, let's keep those together. So button state, actually we don't use button state anymore then. Yep, and those, in that case, let's stick them into maybe single struct. Here, so struct buttons like that. And here we will just then add buttons of type buttons. And let's, instead of doing this, so let buttons enter, left and right. Okay, and then we just take it here and it's buttons. So it's that, yeah. And notice buttons. So enter, left and right equals buttons. Ah yes, I mean here. Okay, I think it's looking good. So just confirm that it's working. Okay, so still flickering, but at least it's working. Okay, somebody came home right now, so I think it's a good time to stop it. Yeah, talk to you, bye bye.